When creating coding assignments, coding labs, there are a number of different test cases that you can create. One of the first entry points, one of the places that you should really start auto grading is with compare output tests. With a compare output test, you run the student's code with certain provided lines of input, and you get a particular output. The student's output is then compared against your expected output based on the compare method you select. You can compare the student's output, code's output, to identical to your expected output. You can compare it with some flexibility, ignoring things like uppercase and lowercase differences, white space differences. You can check to see if the value that you're expecting is somewhere in the student's output. You can even write your own regular expressions to customize this comparison any way you'd like. For example, I have here an expected output of the word hello. If I run this test, I can run it to see what will happen. It has failed. What students would see when they run a test like this is a diff output showing the actual output of the student's code versus the expected value. And it will highlight the differences between the two. So you'll notice here the student's code actually had extra characters. It said, hello world, this is Python 3, where the expected output was just hello. If we simply edit this code, run it against the tests again, you can see it passed, and there's no highlighted differences now with a pass test, as the expected output and the student's output is the same. If the student's code expects lines of input, you will need to provide those lines of input in order to properly do an output comparison. If I was to run the test case against this without providing lines of input, it will immediately fail because it reached this line of input without actually having anything to provide the program with. Once I provide a line of input, it will use that in the actual program when the computer asks or the program asks for some input. I expect the output to say hello in the name that I provide. And you'll notice the test passed, given Mazone. Of course, a student could just output hello Mazone. So typically when you make input-output comparisons, you want to provide multiple tests. I always say a minimum of 3, the triangulation I always mention, a minimum of 3 tests in order to ensure that the student's code is doing it as you'd expect. So for instance, I'm going to copy this test. I'm going to change it to say other names. Joe should say, hello, Joe. Add a third test. Make that name say Jack. Hello, Jack. And if I run the tests, because my solution does work where it takes the name and it uses that name, all 3 tests will pass. Giving him Zone, giving it Joe, giving it Jack. Again, you want to make sure you do multiple tests so a student just doesn't hard output exactly what you'd expect them or exactly what your test is expecting. Output comparisons are a great first step in auto grading student code. But as you continue through coursework, of course, output tests won't always do the trick. So you need other methods to test student's code. Typically, we use unit tests. Unit tests help us test units or different modular components of the student's code and assert that they meet certain conditions that we identify as part of our test case. For example, we may take functions or methods, classes, certain files of a student's coding project and test those individual components to make sure they're doing the job we would expect them to do. For example, imagine that we have students define a function named add5 that takes in a parameter of an integer. And this function is supposed to take the parameter value and add 5 to it and return the result. This function definition alone doesn't produce any output. So I wouldn't be able to test the student's function here to ensure that it's doing its job. So I would need to create a unit test to do this. There are different unit testing frameworks for different languages that you may use. For instance, here I'm writing a Python script, so I can use Python's unit test library to test the student's code. Java, you would use JUnit. JavaScript, you could use Jest or Jasmine. C++, you could use Google Test, Ruby, RSpec, C# NUnit, Ccheck, and there's a number of other unit testing frameworks out there, and that we will also be making available. Inside the actual unit test code, we need to define if there's anything we want to happen in a setup before we actually test the student's code. Is there anything we want to do after we test the student's code? And what we want to do to actually test the student's code. For this example, there's nothing we need to set up or clean up after each test is run. So we could remove these. You only need the setup and the teardown when it makes sense for the test that you're building. First thing we would do is, in order to use another Python file in a Python script, you need to import that file. In this case, the student's code is named main.py, so I would import main. After that, we can create assertions. The assertion is the important part of telling the test, if the test should pass or fail. So we can assert a particular condition. For instance, this asserts true. If the value inside these parentheses evaluates to true, then it will pass. What we're going to do is we're going to assert equal, meaning we're going to compare one value to another value and assert that they're equal. If they're not equal, it will fail the test. For instance, we can say that 10 should be equal to main.add5. That's the function that the student created. If we give add5 5, it should return 10. 5 plus 5 is 10. Another example would be 5. We used main.add5, and we gave it 0. 0 plus 5 would be 5. And you can continue to assert as many of these different conditions as you'd like until you think that the student's code satisfies the requirements. Of course, you want to test different edge cases, negative numbers, zeros, those kinds of things. And it really depends on the actual challenge or the project. When you run the code against the student's code, it will tell you if it passes or fails. any of those things. If there's any errors in your unit tests, so you always want to check just to make sure. For instance, here, I accidentally put a period instead of a comma. Now my tests pass. It'll tell the students all the tests pass. If a particular test does not pass, either because you make an error in the actual test case or the student's code is different, it'll actually tell the student why that particular test failed. It used add 5 with a 1, and it returned 6, but we expected 5. So it'll tell them. Obviously, this is incorrect for the test, but for students, they would actually see something that makes sense if we built the test correctly and their code wasn't producing the proper result. If ever you need more power, more capabilities to run specific tests that you design, you could always write your own custom script test. Here, you can design the exact logic you need to determine if the student's code passes or fails. For instance, in the advanced Scilabs, we have a custom bash script that you can run. When you're writing out this bash script, you can run the student's code and direct the output to a debug file. This debug file is any of the output that you want to show students to help them debug their code. You can do any comparisons that you'd like. You can run other files. You can write to a feedback file. And any of the text that you write to the feedback file will show to the student as feedback for the test failure. And in order to determine if the test passes or not passes, or passes or fails, you'd write a P to the result file or an NP to the result file for not passed. You can also, when you determine if the code passes or fails, you can add a semicolon and a numeric value in order to give the students a certain number of points, let's say as partial credit. By default, it will give it all the points the test case is worth. Additionally, you can add other files by creating files or uploading them to bundle with the test so that you can have unit testing frameworks, other executable files, data files, or anything that you need in order to support your custom script and check the student's code.